Hey there, folks. So maybe you're familiar with how to find X, which is really just any number, typically. And it can be any variable too. It can be Y, Z, gamma, whatever you want. Maybe you're familiar with how to find that without fractions involved. But today, by popular demand, we're going to look at how you would find X, find some unknown variable when there's a fraction involved. So let's just make up an example. And I'm going to tell you that the um, the hardest part of being a math teacher is no doubt the fact that everything has to resolve to something that matches up with your learners. So, for instance, if you're not into remainders, if you're not into decimals and those types of things, then you have to make sure everything resolves to a whole number. So, I'm just making this up, so we'll see what happens. As we go through, there are a couple ways that you could tackle this, but I want to first start with a little philosophy here. You see this fella X? So X, you want to get X by himself, right? You want to get X by itself. And there's an old saying that says, "Get out of here, kid. You're cramping my style," right? So I always say that everything else is cramping X's style. So we want to get X by itself, and you have to do this in the proper order. Now, you may have heard about PEMDAS, which there's lots of different ways of remembering it, but please excuse my dear Aunt Sally is an interesting one that I've always held on to. And you may be familiar with some other way of remembering that. But basically, we could tackle this by distributing the 1/3 within the parentheses or across the parentheses and then solving. But in this case, I'm going to go ahead and tackle it right away. So I'm going to say that 1/3 is its own number and that it's cramping X's style. And it's cramping it by being multiplied. Okay, there's a pretend little dot or a little baby X there or whatever you want that shows that it's being multiplied. And so we want to talk about this idea of opposite operations. Opposite operations are literally the opposite of operations. So adding has an opposite of subtracting, subtracting with adding. Multiplying has its opposite with division, division with multiplying. So how do you uncramp style? If you're being multiplied, you do the opposite operation and you divide. Okay, now with fractions, you can divide by 1/3. That's no problem. All right, make a big little divider here. Big little, you ever hear that? 1/3. Look, it doesn't matter if I make it flat or if I make it at an angle, it's still 1/3. I can divide 4 by 1/3. Boom. Okay, well, that's easy. No problem there. Let me get a better color. There we are. I know that 1/3 cancels out with 1/3. Now I'm left with this bugger over here, and I might as well take care of that now. So I'm going to rewrite this. What's left? X plus 9. Do I need the parentheses anymore? No, I don't, because it's not really helping me anymore. So X plus 9 equals 4 divided by 1/3. Well, did you guys know that everything is a fraction? So 4 is actually 4 over 1. That's actually really helpful because the easiest way, I think, to divide by a fraction is to do what we call copy dot flip or keep, cross, multiply, whatever, I don't know, reciprocal. You take this value, you say, okay, well, that's equal to 4 over 1 divided by 1 over 3. And we copy, means you take the first one or keep it, depending on how your instructors have talked to you about it. Dot, which means multiply. See, we're doing the opposite operation here too. Dividing, we're doing the dot. And then you flip. So you take the reciprocal. 1/3 is 3 over 1. See? And again, I know that, sometimes I write it with a slash like that. Sometimes I write it like that. They mean exactly the same thing. And so what do we end up with? We end up with 4 times 3. Do you know what that is? Sure you do. It's 12 divided by 1 times 1, which is 1. And that actually 12 over 1, just like 4 was 4 over 1, 12 over 1 is 12. Oh, great. Now look what we've got here. This big old mess and our brains just shut off, right? Well, here's what we had to begin with on that side. And we figured out that this big old mess is now 12. So we're going to take it again. X plus 9 equals 12. Oh, this is much more familiar territory, isn't it? Okay, so still, though, X isn't by itself. 9 is cramping X's style. How's it doing it? By being added. Well, let's see. The opposite operation is to subtract. So we're going to go ahead and subtract 9. I like to do it right underneath. I'll bet you do too. I know that if I have positive 9 and a subtracting 9, I'm going to end up with 0 here. On this side, I'm going to have 9, 10, 11, 12. 3. Hey, what do I got? I end up with, do you guys like arrows? I love arrows. X equals 3. Now look, you really could go back now that you have X over equals 3. Circle it for your teacher, by the way. They'll love it. X equals 3. That means you could actually go back to this and find out if it was correct. Let's rewrite the original question, or the original equation, rather. That was 1/3 X plus 9 equals 4. This is the check side of things. Pretty useful. 1/3 times, there's 3. 3, substitute that in, plus 9 equals 4. Let's see. 9 and 3, parentheses first, that's 12. 1/3 times 12 equals 4. Ooh, that's 12 over 1. Everything's a fraction, right? So that's 1 times 12 is 12. 3 times 1 is 3 equals 4. And if you did that, however you like to divide numbers, this would actually be a division fact, right? A multiplication fact turned on its head. Then 12 over 3 really is 4. In other words, 4 3 times is 12. 4 plus 4 plus 4. 4, 8, 12. In other words, we get to give ourselves a great big, and let's make it fat. A great big fat check mark. Okay, folks, that's everything. Any other questions? Just let me know. I'll make a video.